Hello! Yes! And welcome to our Objective 1.4 notes. And Objective 1.4 says, I can identify a function as even, odd, or neither. So let's talk about what even and odd functions are. Even functions are functions where f of negative x equals f of x. So what does that mean? Well, that means that when I plug in a negative value for my input, it'd be the same as if I plug in a positive value. And that means that even functions are symmetric to the y-axis. All right? So think about it this way. If we have a graph that is even, the negative side will look the same as the positive side, right? This side, the negative x, will be the same as the positive x over here. All right, so symmetric to the y-axis are even functions. Odd functions are functions where f of negative x equals the negative f of x. All right, and these functions are symmetric to the origin. And what I mean by that is that these functions, let's say, let's do one like this. These will look like so, where the negative x is the opposite of the positive x. So if I have a negative x and I'm going down, for the positive x, I'd be going up, and vice versa. So if I had a negative x that was going up, the positive x would be going down. So to determine if a function is even or odd is very straightforward. Now you're probably wondering, well, what about the neither functions? Well, neither functions are functions that aren't even or odd. It's very possible for a function to be neither. That is actually probably more common than a function being even or odd. But that being said, let's figure out how to determine algebraically if a function is even or odd. So all I need to do is, step one, plug in f of negative x. All right, and then I'll simplify that expression, and then I'll see, does my simplified expression f of negative x equal f of x? If so, it's even. If not, well, it might be odd. So that process is actually the same. I'll also plug in f of negative x. So I really only need to do this once. And then I'll simplify again. And I'll say, well, this time, does f of negative x equal the negative f of x? So one thing that I like to do at the beginning, f of x is the original statement we're given. I like to write negative f of x. And negative f of x just means switch all the signs of f of x. So let's do this together with letter A. So what we're going to do is we're going to determine if it's even, odd, or neither, and then we're going to graph it also to check our work. So f of x is x to the third plus x, which means that negative f of x is switch all the signs. So it would be negative x to the third minus x. So now to simplify, or now to perform the test, I plug in negative x. So I would have negative x to the third plus negative x. Anywhere there was x, I'm now plugging in negative x. So let's simplify this here. Negative x to the third. So negative x times negative x times negative x. That would give me, indeed, negative x to the third. Adding a negative is the same thing as subtracting. So that would leave me with negative x. All right, so this is what f of negative x equals. Does that match f of x? No. Does that match negative f of x? Ah, yes, it does. So you're telling me that f of negative x equals the negative f of x, which means that this function is odd. Okay, which means there should be symmetry to the origin. So let's check the graph to see if that's right. Here is the graph of x to the third plus x. Notice we are symmetric to our origin, right? We're going down as we go left, we're going up as we go right. We have origin symmetry, therefore we can be pretty confident that this is indeed odd. Now on our graph we can sketch Again, there's really no need to label points or anything like that, just a rough sketch to demonstrate that odd function is symmetric to the origin. Okay, let's try another. Letter B, x squared plus 1. So let's start by saying negative f of x. So in this case, this would become negative x squared minus 1. Change all the signs. So now I need to perform f of negative x. So I plug in anywhere there's an x, I put in negative x. So negative x squared plus 1. Simplify negative x times negative x. When I square it, that would become positive. So f of negative x would become positive x squared plus 1. Now, does this match our original f of x or the negative f of x? Looking at it, x squared plus 1, hey, that does match f of x. So that means that f of negative x equals x squared plus 1. And this equation then, since f of negative x equals, goodness, I already wrote that. I should say that it equals f of x. Since f of negative x equals f of x, this is an even function. All right, now the graph of this one would be a parabola that has been shifted up 1. Kind of discussed these earlier. It would look just like that. Symmetric to the y-axis, right? That y-axis is going to be the line of symmetry for this parabola. All right, and that's even, odd, or neither. If we're feeling good, go ahead and check out the practice problems. If you want to learn a little bit more, get a little bit more information before you do those on your own, go ahead and check out that sample problems video. All right, this is Mr. Carter signing off. I'll see you next time.